Welcome to your podcast for Lesson 25, Net Force and Free Body Diagrams. After viewing the podcast, you should be able to draw a free body vector diagram and use vector addition rules to find the magnitude and direction of the net force. For your warm-up for class tomorrow, I would like you to calculate the weight of a 1 kilogram wood block, and I would like you to also state its mass. Just like we've done for several of our problems this year, drawing a diagram is going to be very useful. And so for solving problems with forces, we're going to draw free body diagrams. So we're going to give this one a try. I'd like you to draw a wood block sitting on a table. Okay? So there's a table, and there's my wood block. Now I know that this wooden block has mass, and therefore it's going to have gravity acting on it. And so we know it's going to have a weight, which we learned we label FW, right? So it's mass times gravity. Weight always acts downward. And we know that since this block is sitting on the surface of a table, we know that it is also going to have a normal force. Okay? The normal force is going to be perpendicular to the contact surface, and because we know the block is not going through the table nor floating up in the air, that normal force is going to be equal and opposite to weight. Okay? So because we know that my normal force is equal to my force of weight, I know that my F net is equal to 0. Okay? They cancel each other out. And so what I would like you to do for class is think about, would a wood block moving at a constant speed look any different? Okay? So if it were moving at a constant speed, would the net force be any different? In a lot of cases, your free body diagrams that you draw are going to have several forces acting on them. So you see here with example number 1 and example number 2, there are several forces acting on these blocks. So let's take a look at example number 1. And what we can do is sort of simplify these drawings. So if we look at example number 1, and let's just look at, in particular, force number 1 and force number 3. Force number 1, we know, is moving in the upward direction at 10 newtons, and force number 3 right here is moving in the downward direction at 10 newtons. And so just like we saw in our last picture that we drew, where we had the normal force equal to the weight, if these two forces are equal to each other, they're in essence just going to cancel each other out because they're in opposite directions. So equal and opposite are going to cancel out. Okay? Now, if we take a look at what's happening here with force number 4 and force number 2, force 4 we see is acting towards the left with a force of 7 newtons, and force number 2 is acting towards the right with a force of 12 newtons. And so we can simplify this in the same way. We learned very early in the year that forces going in opposite directions, we can subtract them. So if I have 12 newtons to the right and 7 newtons to the left, and they're going in opposite directions, all I have to do is subtract them. Okay? And so overall, my F net is going to be 5 newtons to the right. And we can draw that then with a vector. Okay, with a vector. Okay. If you look at example problem number 2, in example problem number 2, we now have 2 forces going to the left and only 1 to the right, and we have 1 going up and down as well. So it doesn't matter which ones you start with. Let's just start with the left and right directions on this one. And so I know overall to the left I have 3 plus 12 newtons for a total of 15 newtons acting to the left, but I also have 15 newtons acting to the right. And so even though there's 2 forces, because when we add them together they equal 15, these two are going to cancel out with force 2, the 50 newtons going to the right. And so we're left with, again, force 1, which is 10 newtons moving upward, and force 3, 13 newtons moving downward. And so I would just simply subtract them because they're going in opposite directions. and we know that will leave me with a force of 3 newtons, and I know that that force is going to be moving downward. Okay? So my F net would be 3 newtons downward. So far we've seen forces going in complete opposite directions in both example number 1 and example number 2, and so all we've had to do is subtract them to simplify and to solve for our F net. But as you can see in example number 3 and 4, that is not always going to be the case. And so let's take a closer look at example problem number 3. Notice in number 3 we have 2 forces. We have F1 acting in the upward direction at 10 newtons, and we have F2 acting towards the right with a force of 10 newtons. And so let's go to a blank screen and see if we can resolve these 2 components and solve for our F net. Alright, so I've redrawn the diagram for us, and you can see I've got F1 acting in the upward direction at 10 newtons and F2 acting towards the right with a force of 10 newtons. And so I'm going to simplify this drawing by taking our x and y components and creating a resultant vector just like we did in previous chapters. So I'm going to use my parallelogram rule here to create my F net. Okay. Now, if you remember, by doing that, what I've done is I've created right triangles, and it doesn't matter which one you look at because we know that F1 is 10 newtons, and so that's equal to that side. And if you look, we have 2 sides that we know with our right triangle, and we're looking for F net, which is our hypotenuse. And we know that when we have 2 sides of a right triangle, we can use Pythagorean theorem. Okay? So my Pythagorean theorem is going to tell me that F net squared is equal to F1 squared plus F2 squared. Okay? And when I find F net, I know I'm going to be taking the square root of that quantity, so 10 newtons squared plus 10 newtons squared. Okay. And when I plug and chug all of that into my calculator, I get 14.1 newtons. Okay. So my F net is equal to 14.1 newtons. Take a look at example problem number 4. In example problem number 4, we have 3 forces acting, F1, F2, and F3. F2 is acting with a force of 15 newtons towards the right, and F3 is acting with a force of 15 newtons in the downward direction. And so what that does for us, because they're equal in magnitude, should tell you that when we do our resultant vector for this, and we'll label it FR, that is going in the direction that's completely opposite of our F1 vector, and so if we find FR, we can simply subtract. Now I know that it's going in the complete opposite directions, again, because F2 and F3 are equal in magnitude. What that does is tell me that these 2 angles are equal to each other, and so they would both have to be 45 degrees, since this whole thing is 90. Because these are 45, and our F1 was acting at an angle of 45 degrees above the horizontal, I know that F1 and FR are acting in complete opposite directions of each other. So let's simplify this on a blank screen. Alright, so here's our recreated drawing. And so I know that I can solve for my FR, which is opposite of that right angle, making it our hypotenuse, by using our Pythagorean theorem. And so I know that FR squared is going to be equal to F2 squared plus F3 squared. Okay. So I can find FR by taking the square root of the quantity 15 newtons squared plus 15 newtons squared. And when I plug and chug all of that into my calculator, I get 21.2 newtons. Okay. So again, that is going to be going in the complete opposite direction of my F1. Okay. And so I can find my F net then simply by subtracting these 2 values. I'm going to take my FR, because it's the larger magnitude, and I'm going to subtract F1 from that. Okay. So F net is equal to 21.2 newtons minus 10 newtons, okay, which is going to give me 11.2 newtons for my F net. Now I know that my F net is going to be acting in the direction that FR was pointing, and I can be very specific about that direction, and so I know this angle right here is 45 degrees, and so what I can do is say that my F net is acting at 11.2 newtons, okay, 45 degrees below the horizontal. And again, I knew that that was a 45-degree angle because my F2 and my F3 were equal to each other. And so what that means is, again, that those two angles have to be equal to each other. And since the whole thing is a right angle, 90 degrees, half of that would be 45. Okay? And so my final answer, F net, is 11.2 newtons, 45 degrees below the horizontal. So I'd like you to try example problem number 5 for class. Notice that you have two forces acting on this object. F1, which is acting at 60 degrees above the horizontal towards the left with a force of 20 newtons, and F2, which is also acting with a force of 20 newtons, but this time at 60 degrees above the horizontal towards the right. And so my hints to you are to split F1 and F2 into their x and y components, and then once you have that done, just sum up the x components and the y components. When you look at this, notice that if we take our F1, we're going to end up with an Fy and an Fx going in those directions. And if we do the same thing for F2, notice that we're also going to have a force acting in the upward direction and also towards the right. And so once you have it simplified to look like this, it should be very easy to figure out what to do with these two guys because they're going in opposite directions. But then notice you've got two forces here going in the same direction. Think back to what we learned before. If you have two vectors going in the same direction, what do you do to them? All right, so I'd like you to also try number 6 for class, and I'll tell you what, if you can get number 6 with the F net and the angle at which that F net is acting, I will give you 2 bonus points. Okay, it has to be completely right, so no partial credit for this one. But I will give you some hints. So if you look, we've got F1 and F2 acting on this object, and just like in all the other problems, if you can take your F1 and F2 and take those resultants and find the x and y components, okay, you can simplify the drawing. Okay, and so here's my hint to you. It'll kind of look like that. Simplify that. And then once you have that, you can find your F net. Now don't forget to find the angle. You're going to use the inverse of our trig functions. So the inverse of either sine, cosine, or tangent. And again, if you can solve this problem for me and show me the answer in class, you'll get 2 points extra credit.